Chapter 9, Transformations, Section 1, Translations, which are when you slide a figure. Just a few vocabulary reminders about transformations. A transformation of a geometric figure is a function. It's one-to-one. So if you put something in, you get something out, just like we did with functions last year in algebra. Or a mapping that results in a change in the position, shape, or size, this one's going to be for dilations, of the figure. In a transformation, the original figure, what you start off with, is called the pre-image, and the resulting figure is called the image. Some transformations preserve distance, corresponding side lengths in the pre-image stay the same length in the pre-image as it is in the image, as well as preserve angle measures. The ones that preserve distance and angle measures are called rigid motions. So as an example, in the diagram, quadrilateral EFGH is being mapped to quadrilateral E prime, F prime, G prime, H prime. So E is being mapped to E prime, F is being mapped to F prime, and so on. The first question asks, what are the images of angle F and angle H? The images are what happens after you map it. So if this is EFGH, the image of angle F will be angle F prime. The image of angle H will be angle H prime. You know that we normally say by 3 points, so it should be angle EFG is being mapped to angle E prime, F prime, G prime, and angle GHE is being mapped to angle G prime, H prime, E prime. The next question asks, what are the pairs of corresponding sides? Well, EF and E prime, F prime, EH and E prime, H prime, and so on for the corresponding sides of these two figures. So even though it's been translated, these sides are still corresponding. They're going to be the same measure, so they're going to be congruent, and angles are going to be congruent. So these are congruent figures. It was just translated. An isometry is when length is preserved. So the figures are congruent. The different pieces are congruent to each other. Orientation is referring to the arrangement of the points, so relative to one another after a transformation has occurred. So in other words, we have direct isometries or opposite isometries. Isometries preserve the distance, and direct means that orientation is preserved. So if we look at this example, if we look clockwise, it goes A, C, B, and in the image, clockwise, A prime, C prime, B prime. So orientation was preserved. It's an isometry because the length was preserved. Therefore, it's a direct isometry. Now, an opposite isometry is when orientation is not preserved, but length is still preserved. So either clockwise or counterclockwise, that's what we're looking at. If we look here at this reflection, if we look clockwise, it's A, C, B, but here clockwise is A prime, B prime, C prime, so they're not in the same order. Or if we look counterclockwise, A, B, C, A prime, C prime, B prime. So orientation is not preserved, but length is still preserved. So it's an opposite isometry. Now, a translation is a transformation that maps all points of a figure the same distance in the same direction. It's usually written as capital T, A, comma, B. The A tells you how many to move the X coordinate, and the B tells you how many to move the Y coordinate. So of the pre-image P, X, Y, that makes the image P of X plus A, Y plus B. So a translation now is a rigid motion. So this is important because we're going to tell which are rigid motions and which are not. Under a translation, distance, angle measure, collinearity, so if 3 points are in a line, they're going to stay in a line, and midpoint are all preserved. So let's try an example. We're asked, what are the vertices of triangle PQR after this translation? So the x-coordinates are going to have -2 added to them, and the y-coordinates are going to have -5 added to them. And then they want us to graph it. So we have our original graphed, and this should be done on graph paper, just a small square. We have point Q, point P, and point R. P, our coordinates are 2, 1. Q, our coordinates are 3, 3. And R, our coordinates are -1, 3. So we're going to add the -2 to the x value, and we're going to add the -5 to the y value. So if we take P, 2 minus 2 gives us 0, and 1 minus 5 gives us -4. So P prime is going to be 0, -4. We do the same thing with Q. 3 minus 2 is 1. 3 minus 5 is -2. So Q prime is 1, -2. And finally with R, -1 minus 2 is -3. 3 minus 5 is -2. So R prime is -3, -2. We graph the image of PQR. So P prime, Q prime, R prime is the image. PQR is the pre-image. We first graph the points and then connect the lines.